so as we look at example 2, one of the first differences I want to point out that I didn't mention in example 1 is that it helps if you're contemplating what the shape of the graph is. So here I have a circle, and here I have an ellipse, and when a circle and an ellipse intersect, it would be reasonable to consider that there would be 2 places. It is possible that there are even more than 2 places where they intersect, but in this case 2 is reasonable. What happens though with an example 2 is we have a parabola, which we know because there's an x squared but no y squared, and we have a line. So I want you to take a minute to visualize for yourself, what do you think a parabola and a line, like what's the most number of places that they could intersect, what's the least number, are there any variations in between? Now I will remind you that our choice here is for the substitution method. And so within the substitution method, what we're going to do is realize that both of these equations equal y. So we could immediately set them equal to each other. That would be an option for us. When we set them equal to each other, we would probably choose to get everything on one side so that we could then factor, because when everything is set equal to 0, that gives us that capability to factor this equation. Now this equation is fairly straightforward with factoring. However, if you do have any issues because that's something that you've forgotten, just again reach out to Ms. Olson for some additional options on, review on factoring methods. So you have x equals -1 and x equals -6 as our potential x values where solutions will occur. But what you want to remember is you're going to put this x value into either of these equations. To be honest, it should not matter which you choose because both of them equal y, which means they equal the same thing. However, if I'm trying to figure out which one is it easier to substitute -1 into, I would argue that by far it is the second equation because in that second equation there is less to do. So if I take this x is -1 and I put it into my equation, I can figure out pretty quickly that when x is -1, I get a y value of 2. So that's a very direct relationship with what's happening. And if I contrast that to when x is -6, right, I'm still going to go to the same location. I'm still going to use that same equation that's the simpler option. But when I put -6 in, I'm going to get a value of -3. So when I pair these two together, putting the x before the y, I get my second solution, right? Put a little and here between them. But what I want to be aware of is, does this -1 also go with a -3? Well, if I want to know if something's a solution, I can remind you that if you put the x into either equation, you should get the y value. So let's try it. If I put a -1 in here, -1 squared is +1, 1 minus 8 is -7, -7 plus 9 is not -3. So when I have a -1, the only solution I get is 2. And that's important and certainly will be later when we examine example 4. So these are the two solutions to example 2.